Hi everyone, welcome back to my channel Chemistry World by KK. So today's topics favorable condition for the formation of ionic bond. Okay, favorable condition for the formation of ionic bond. In this ionic bond, the metal, okay, that is M plus metal gives rise to atomic size large, ionization energy low. So metal in non-metal atomic size small, electron affinity low. So N minus, it form M plus N minus, released energy high. So lattice energy also high. So this M plus N minus attraction strong. Okay, so metal atom should have large size and low ionization energy. So metal atom have atomic size large and low ionization energy. Non-metal atom should have small size and electron affinity high. So lattice energy should be high. Next, lattice energy. So what is lattice energy? Released energy during formation of ionic bond or released energy during attraction between ions. Okay, released energy during formation of crystal lattice of 1 mole of ionic bond. Okay, so that is Na plus, it is gaseous form, plus Cl minus, it's also gaseous form, it forms NaCl, it is solid. So 1 mole of sodium and 1 mole of chlorine form 1 mole of NaCl, it is a solid. Okay, the structure Na plus Cl minus, Na plus Cl minus. Okay, crystal lattice, it is crystal lattice. Next, determination of lattice energy. So lattice energy is determined of following two methods. First one, Born-Haber cycle, that is BHC, and second one, Born-Land equation, that is BLE. The first we will discuss Born-Haber cycle. The definition is lattice energy is calculated experimentally by a cyclic process which is known as BHC. Okay, lattice energy is calculated experimentally by a cyclic process which is known as BHC. So Born-Haber cyclic is held in following 3 steps. Okay, Born-Haber cyclic is held in 3 steps. The three steps are conversion of solid metal and gaseous molecule into gaseous atom. The second one, conversion of gaseous atom into gaseous ions. The third step, conversion of gaseous ions into crystal lattice of ionic compound. Now we will see the example. Okay, Born-Haber cycling for NaCl. So sodium chloride. Na, it is gas, plus Cl2. Cl, gaseous form. Its form NaCl. It's solid in the presence of delta HF. It is a direct process. In this Born-Haber cycle for NaCl, so NaCl, it forms what is first step, conversion of solid metal and gaseous molecule into gaseous atoms. So one is solid, it is gas, both are form gaseous form. Delta H form Na, it is gaseous form, and Cl, it is both gaseous forms. The next one, the next step, conversion of gaseous atom into gaseous ions, means both are gaseous form but it forms anions, that means cation 1 anion 1. Its form Na plus Cl minus. Okay, the third step, conversion of gaseous ions into crystal lattice of ionic compound. So these both are combined. Lattice energy, it is indirect process. Okay, so that is delta HF is equal to delta H plus ionization energy plus of 2 delta H dissociation plus electron affinity plus lattice energy. Okay, this is the equation. Next, second one, Born land equation. So what is Born-Land equation? It is used for compare the lattice energy of ionic compounds. According to bond length, lattice energy is depend upon the charge and size of ion. So the equation is U proportional to Z plus into Z minus by R plus R minus. So what is Z plus? Charge of cation. Okay, what is Z minus? Charge of anion. So what is R plus? Radius of cation, R minus radius of anion. Okay, so Z plus into Z minus, both Z plus into Z minus is equal to product of charge. R plus R minus is equal to interionic distance. It has three cases. The case 1, if Z plus into Z minus are different from given or different from given organic compound, then the equation is U proportional to Z plus into Z minus. Okay, for example, order of lattice energy for MgS and Na2O. So Mg is plus 2 outermost electron and S minus 2, thus Na2 plus 1 oxygen minus 2. So Mg, it has 2 and it has 2 into, okay, 1 into 2, that is 4. It has 2, so what is greater one? 4. Okay, so MgS greater than Na2O. In second case, if Z plus Z minus and R minus is similar for given ionic compound, then we have to use U proportional to 1 by R plus. Okay, if in the question ask R minus, the equation U proportional to 1 by R plus. Okay, for example, order of lattice energy for Na plus, Cl minus and Cl, it has Na plus, Cl minus, Cs plus, Cl minus. So 1 1 to 1 1 into 1 1, they are same. The equation U proportional to 1 by R, it's then the answer NaCl greater than CaCl. So same. In the case of third one, if Z plus into Z minus and R plus is similar for the given ionic compound, then the equation is U proportional to 1 by R minus. Okay, if the question asks R plus, we have to use R minus. The question asks minus, then the equation is R plus. Okay, now the example of in third case, order of lattice energy for Na2S and Na2O. So Na2 plus 1S minus 2, Na2 plus 1 oxygen minus 2, 1 into 2, 1 into 2, so 2 2 same, Na2O Na2S. Okay, did you understand second and third case? If you understand, what is the difference in two cases? In two cases, in the question ask R minus, so in the two compounds the first one will be greater. Okay, in the case 3, if you ask R plus, the second compound will be greater. Okay, so next, applications of lattice energy. Stability of ionic compound is depend upon lattice energy. Lattice energy increases, stability increases. So the equation stability proportional to lattice energy. So melting point and boiling point of ionic compound are also depend upon lattice energy. Lattice energy increases, attraction between ion increases, melting point and boiling point increases. The equation melting point and boiling point proportional to lattice energy. Next, solubility of ionic compound is also depends upon lattice energy. So NaCl plus H2 gives rise to NaOH plus HCl. So NaCl, Na plus Cl minus, HCl, H plus Cl minus. So it is a cross. Okay, NaCl, HCl. So next, for the solubility of ionic compounds, it is necessary that they must dissociate into ions. So lattice energy decrease, attraction between ions decrease, attraction between ions decrease, easy to formation of ions, solubility increase. The equation solubility proportional to 1 by lattice energy.